So a short while ago, I did a video with a bunch of things I've received, and I revealed that I had an internet button, which I've not managed to do anything with yet. So what I'm going to do today, open it up, see if I can get it to do at least a few basic things like light an LED, button presses and so on. And if there's time, we'll see if we can connect to some sensors. So I've went through this briefly before, but we'll just recap. So it comes in this lovely pot. It's actually a very small micro, this little thing here, not unlike the ESP8266. It's a bit pricier, but what I'm led to believe, now it's Wi-Fi based, it runs code, it's got some GPIO pins, but I'm led to believe it's much easier than the ESP8266. So apparently I don't need any specific specialist software on the PC. I should be able to power it up, find out how to connect it to Wi-Fi, and then let's see where we go with that. So I think the first thing I'll do is we'll open this box up and see what have we got. It's got some setting up Wi-Fi stuff here and a cable. So, well, that's one of the shortest USB to micro USB cables I've seen. But I suppose it's got to fit in that little can, so it's fit for purpose. Designed for an envelope. Okay, we'll pop this in here and over here, and it has power and there are lights, so it's alive. Go to spark.io, button start. Oh, and my laptop has just acknowledged that there's something there. For a start, there's a rather nice guide, the internet button. Congratulations on receiving your brand new internet button. It's very nice, helpful carry tin with a USB cable, clear plastic module cover, opaque plastic shield cover, and the photon resting between the two removable covers. Yes. So let's turn the internet button over so we can see the components. You've got 4 buttons, a buzzer, space for a JST connector so you can actually solder in a power instead of a USB power. So you can also see the top of the shield. Okay, let's have a look at that. So before I connect it, I notice there's also tiniest little coax port, maybe for an external aerial. Okay, so I've popped that out and let's see the top of the shield. Ah, okay, so this has got to be the accelerometer and here are the exposed LEDs. Now, just looking at those LEDs, I reckon they are WS2812, so I reckon those are RGB LEDs, and I suspect they're all connected to one pin. And I like the way they've done this. So, the top of the board here, you can just see pins, or you can just see exposed pads, and they've connected this to the back of it. And that's a very interesting way. I've not seen that before. So you've got a 3-volt power supply, ground power pins, microcontroller, LEDs, button, accelerometer. I'm sure there's plenty of fun to be had with this. We've got a connect to USB section. Let's jump straight into there. I've got to install Node.js, which is rather handy because I do have Node.js. We need a particle driver. We need command prompt, the particle CLI, connect to this. I mean, let's see what the mobile version is like. That will do as a suitable mobile device. Running Android should be able to handle this. Particle mobile app. So they highly recommend that for first time setup. Okay, here is what the particle screen looks like. So let's tap get started. Okay, so first thing it's asking me to create an account on their website. I gotta be honest, just to get to program a microcontroller, I'm not very keen on this model. But anyway, we'll see. Maybe it's worth it. So there's a plus button. Let's see if I can do this. Set up a photon. Well, I believe this is a photon, the particle board. Photon AESL. That's the only photon it's found, so that will do. So that actually, once you're logged in and registered, and this is turned on, it's relatively easy to get it connected. I suppose the next question is how do I program it? So it says this may take a little while, but don't worry. It will take 6 to 12 minutes. So this is sending the Wi-Fi credentials to the photon. Ah, look, it's gone green now. It's gone from blue to green. Blink purple for the next few minutes as it downloads updates. So it's blinking purple and it's downloading updates. This tablet was disconnecting from my network, connecting to here, assigning this a way to connect back to my network, and now it's given this a funny little name. It's called it Plumber Cowboy. So let's see, if I click on the device, I must be able to do something. Welcome to Tinker. Tinker is the fastest and easiest way to prototype and play with your photon. You can access the basic I/O functions without writing any code. Okay, so I can do basic turning on and off. Be nice to know what I can do to get code running on it. Okay, so what have we got? A pen device, which allows me to change the name of the device, and then pins. So if I take D0, and then I can do digital write, and if I long press, it can be analog write. Nothing happening there. There was a click. I think that pin sounds like it's connected to the buzzer. What the guide isn't telling me with the internet button is what these lights and LEDs are connected to. So let's see, if I go back to the internet button, okay, so I click back in the browser, past getting it connected. There's some example libraries, blink and LED, internet button. No, this doesn't actually say. There's a bit of a disconnect going on here then. What this documentation isn't telling me, and I think is critical. So I've set up with the tablet app, which is apparently the easiest way to get connected. The tablet app Tinker is showing me a list of pins that I can turn on and off. What they're then showing me in their guide here is code to write and run on the PC. Code that looks an awful lot like Arduino style C code. What I'm not getting from either is what pin each device here is connected to. D7, there we go. Okay, right, D7 has got a handy LED. So I'm, without any code, I've got the tap to turn an LED on demo. So has anything else documented? If those are WS2812 LEDs, we're not going to be able to get to them to do anything interesting without code. If you go to build.particle.io, then you actually get the place where you can type in, run and put code onto this. So having paired it using my tablet, you'll actually see the same devices you've paired with your account there. You can put C code or C++ code into an environment that's basically exactly the same as the Arduino. In fact, it's even a .ino file, which is a nod to the Arduino setup. And they've got an internet button library designed specifically for this shield here, the internet button shield. There is actually some onboard accelerometer sensors, so we can have a play with those. The first thing I did is I wrote a little bit of code messing with the WS2812s, and I used that to make a small roulette wheel app. So if I hold it down, the button spins, and when I let go, it slows down with a slight random value. I'll link to this code so other people can play with it and do fun things. Let's see what we can do with the sensors. So those are also in that internet button code. And in the build.particle.io, there are a set of icons on the left. And one of them is libraries, and there's an internet button library, which makes it really easy to go and link up and try stuff out. These are full RGB LEDs, and I think this is a good demonstration. So this is what they call their good combination demo. So I'm telling it to flash. There's a flash button. You can hear it disconnecting and reconnecting as it's rebooting with that code. Green LED flashes for a while, which I presume is it uploading the code. The IDE here also shows you any errors as it's uploading, anything while it's compiling. It gives you the normal check options. It's got reasonably nice code color highlighting. It works pretty much as you'd expect an IDE to work, as in a development environment. So if we press a button, different buttons make different lights light. And if we press them all, we get a rainbow. So let me see if I can find something here that demonstrates the accelerometer, which you can use obviously to see if it's being tilted, if it's being moved. I've actually removed it from its plastic case. So I said I'd play with sensors, and there is an app here which is changing LED position. It's based upon the lowest LED according to accelerometer. I also had a look at getting sound out of the thing. So if I load up, now you can actually get the buzzer to play whole tunes, whole little chunks of music. I mean, we're talking a beeper here. We're not talking beautiful audio sampled music. But you see, for again this little roulette game, it's a rather useful sound, or rather perfect for its purpose. To give you an idea of what I mean by the sound not being particularly great, but good enough for a bit of fun, if I upload this thing, which is the music application called Making Music, it's just their little demonstration of it. Just got to wait for it to upload. By the way, it's not uploading. There we go. So it's not uploading via this cable. This cable is just powering. It's actually uploading somewhere via the cloud and then back down via my Wi-Fi. And playing with it a bit longer than earlier, I've now discovered some pretty amazing features. So it has, all of these have an API by which they can publish data to the internet, and you can pick up from it, which means you can put it as a sensor somewhere and have it just constantly publishing data, which its dashboard will automatically graph for you. You can also set up some variables which are registered, where you can ask for their value at any point in time. So if you know the identity of the device, you can say, give me the value of some registered variable, and you can do that in a browser, and it comes back in JSON, which is, all the rage, very good with web scripting and other scripting systems right now. It also, because you can allow it to use for an API to call functions on the device, it's very, very nicely web connected. If I press all of them, there's a rainbow function that does that. So I think actually, all things considered, I wasn't initially into the idea of registering. When you realize it's cloud connected and that I could place this anywhere where it has a Wi-Fi signal, obviously I've registered it with that Wi-Fi signal, I can then reach it from anywhere on the internet, upload new code, I can then register variables, pick up on what's going on at sensors. So actually, as a connected sensor device with a built-in accelerometer device already, that's pretty awesome. That's probably what makes it a more expensive device than the ESP. A robot with an accelerometer could be kind of fun. And one of the things that the ESP hasn't quite got down, or some of the various development environments haven't quite got down, is the idea of pushing new code in the field via Wi-Fi. It is a Wi-Fi device. There are ways you can get the Lua to do the telnet thing via Wi-Fi. This comes with that on board. There are things out there that generate Arduino code from Blockly, so that could be used in a school environment. Again, I mean, it took me a while to get my head around what this thing is about. I mean, the internet connectedness of it, the fact that everything is available or can be fairly easily available via web APIs, via web endpoints, and that unlike doing it on ESP, I wasn't writing server code, I just registered a variable that can be published online. I can register events that are published online, and I can register an API of functions that you can call on this from online. And that's got a very, very high level interface for just getting web access to stuff on it. Once you see that that's what this device is about, and I mean, the particle, not, the shield is a fun bit to demonstrate it with, then you really understand the power of this device.